This video is brought to you by Squarespace, an all-in-one platform for building your brand and growing your business online. Every 30 to 34 million years, our solar system passes through the plane of the Milky Way galaxy. Coincidentally, during this time, as fossil records show, our planet goes through major ecological disasters that wipe large numbers of species off the face of Earth. To put two and two together, let's go back in time, some 66 million years ago. The solar system was approaching the galactic plane. Meanwhile, on Earth, the Cretaceous period was nearing its end. The world looked a lot different back then, with land masses in places you wouldn't recognize today. This was a world of superlatives, where everything was bigger, weirder, and more intense. The Cretaceous was like Earth's rebellious teenage phase, with wild fashion choices and a go big or go home attitude. In the meantime, something was happening to the distribution of land. Continents had begun to form. We have all heard of Pangea, the supercontinent that existed long before the Cretaceous. Well, by this time, Pangea had broken apart, but the continents were still drifting around like puzzle pieces. This period was one of the warmest in Earth's history, with tropical temperatures extending all the way to the poles. This meant that even the polar regions were lush and green, with forests of ancient trees and exotic plants. So where were the mammals, you ask? Mammals during the Cretaceous were small and insignificant, smaller than today's rabbits. Everything that lived on land that was larger than a meter in size was a dinosaur, unarguably one of the most successful animals to ever walk the planet, dominating the world for more than 150 million years. Until that dreaded day, an asteroid bigger than Mount Everest was hurtling towards the Earth at a speed of 43,000 kilometers per hour. For context, the speed of sound is 1,200 kilometers per hour. As it tore into our atmosphere, the asteroid compressed the air in its path, thereby heating up so much that it could have been as hot as the surface of the sun. As it crashes into our planet off the coast of modern-day Mexico, it unleashes chaos on a scale never seen before. The impact is catastrophic. Apocalyptic, rather. The force is so immense that it sends shockwaves rippling through the planet, flattening everything in its path. If a technologically advanced civilization had reached our planet, they'd be surprised to see that the Earth looked very different than what it was when they'd entered the solar system. Yes, planet Earth had changed forever. The mighty dinosaurs that ruled it for millions of years were now reduced to fossils in the Earth's crust. But where did the asteroid come from? Remember we discussed in the beginning how every 30 to 34 million years, our solar system passes through the plane of the Milky Way galaxy. Scientists at the Cardiff Center for Astrobiology have found that as we pass through the densest part of the plane, gravitational forces from the surrounding giant gas and dust clouds dislodge comets from their paths. They're calling it the bounce effect. These comets plunge into the solar system, and some of them collide with the Earth. This is where the asteroid might have come from, changing the narrative that it had actually come from the asteroid belt or the Oort cloud. The Cardiff team backed their claim with a computer model they built that suggests that as we pass through the galactic plane every 35 to 40 million years, the chances of collision with an asteroid or comet increases tenfold. Not only that, when the team matched the models with actual evidence from craters on Earth, it highlighted that we do suffer more collisions, approximately every 36 million years. Meanwhile, in a different study, a scientist from New York University, Dr. Michael Rampino, has suggested that as the solar system passes through the galactic plane, it causes the Earth's core to become superheated, which would cause massive volcanic eruptions and potentially rift apart continents. Before that, let's quickly hear from today's sponsor, Squarespace, which offers the best tools for easy website design. With their AI-backed design intelligence, creating your unique digital identity is fun, effortless, and quick. Their website design system called Fluid Engine lets you customize every design detail with this extremely helpful drag-and-drop technology. Squarespace also has built-in analytics so that you can easily track who's coming across your new page. Check out squarespace.com for a free trial, and when you're ready to launch, head to squarespace.com/territory to save 10% off your first purchase of a website or domain. Now, I don't know if the Deccan Traps ring a bell, but towards the end of the Cretaceous, this was one of the largest volcanic provinces in the world, located predominantly in west-central India, which was on its way to smash with Asia. But what initiated the Deccan Traps is still debatable. And while some theorists believe that it was indeed related to the movement of the Indian tectonic plate over the Reunion hotspot, recent studies hint that it may have been caused by the Earth's core heating up as we passed through the galactic plane. Meanwhile, the scientists from Cardiff suggest that while the bounce effect may have been bad news for dinosaurs, it may also have helped life to spread. They propose that the impact may have thrown debris containing microorganisms out into space and across the universe. This is close to a very well-known and fascinating theory called panspermia that proposes life exists throughout the universe and can be distributed via comets, meteoroids, asteroids, and planetoids. In fact, according to the theory, life on Earth may have originated from microbial life forms that traveled through space and survived entry into Earth's atmosphere, eventually leading to the development of life as we know it. Now, the somewhat bad news. Our present position in the galaxy suggests we are now very close to passing through the galactic plane. But don't fret, as not all scientists believe that the solar system passing through the galactic plane causes an apocalypse. An astrophysicist at the Max Planck Institute for Astronomy, Corin Baylor-Jones, says that it is highly unlikely, and the chances of it are so low that you normally wouldn't bother to mention. If one were to tweak the parameters describing the galactic plane, you could well find completely different results, he says. He also stresses that the model does not account for the fact that asteroids, which are not as far out as the Oort cloud, could have caused the craters. And even if the bounce effect were to cause a global catastrophe, we wouldn't come face to face with it in hundreds of thousands of years. Who knows where we will be by then? But for humanity to carry on its torch, we have to become a multiplanetary species, or else we might face the same consequences as the dinosaurs. What do you think? Drop in your comments to let me know, and if you enjoyed this video, please give it a thumbs up and consider becoming a member. In 2024, a near miss from an asteroid went almost unnoticed, but what it did in passing is very interesting. Asteroid 2024 MK zipped past Earth at a distance of around 295,000 kilometers, unnoticed until just days before its approach. But what made this asteroid particularly intriguing wasn't just its size, but the subtle change in its trajectory as it flew past us. As 2024 MK flew by, our planet's gravity gently altered its path. But why does this matter? Because in 2029, an asteroid much larger and far more famous will perform a similar dance with Earth. 99942 Apophis. The asteroid will pass by at a distance of approximately 31,000 kilometers, and that's closer than many of our satellites. Most of the satellites we rely on every day for internet, GPS, and Earth monitoring operate in low Earth orbit, just a few hundred to a couple thousand kilometers above the surface. But there's another class of satellites in geostationary orbit, far higher up, at about 35,786 kilometers. These satellites remain fixed above a single point on the equator and handle everything, from weather forecasting to global communications. Now, 99942 will pass between these two layers, threading the orbital needle, zipping through a region of space where no natural object of this size has ever been observed flying so close to Earth. Unlike artificial satellites that are locked in orbit, Apophis is on a hyperbolic path, moving too fast to be captured. But even then, Earth's gravity will bend its course slightly, like a slingshot, but not enough to pull it in. Now, before we proceed, I want to make something absolutely clear. We know with high degree of certainty that the chances of the asteroid striking our planet are extremely slim. unless something completely unforeseen changes its trajectory between now and then. Based on the possibility of such unpredictable changes, an astrophysicist at the University of Western Ontario believes the odds of the asteroid hitting Earth are slightly higher than previously estimated. In this video, we'll explore everything you need to know about the so-called God of Destruction, its current trajectory, how it will appear in our skies as it draws near, and whether there's even the slightest chance it could collide with Earth. Welcome to Territory. This is your space. Imagine waking up one day to see something larger than the Eiffel Tower hurtling across the sky. Now, if such a giant were ever to strike Earth, the results would be catastrophic. Scientists estimate the energy released from such an impact would exceed 1,000 megatons of TNT. That's enough to obliterate an entire region, with devastation spreading for hundreds of kilometers around the impact site. But thankfully, we're in the clear for now. However, that doesn't mean it's keeping its distance. On April 13, 2029, Apophis will make a close pass. In fact, this encounter will be so close that it could rattle the asteroid's surface, triggering tiny landslides or quakes that subtly changes its composition or reflectivity. With a predicted brightness of magnitude 3.1, Apophis will be visible to the naked eye from many parts of the world, tracing a path across the night sky over several hours. This would offer a glimpse of what the dinosaurs might have seen as the Chicxulub asteroid became visible in the sky. But since in our case the space rock is only zipping past the planet, it will cover a stunning 205 degrees, nearly 2/3 of the sky. However, an astrophysicist at the University of Western Ontario suggests that the odds of the asteroid striking Earth are slightly higher than previously thought. In his study, published in the Planetary Science Journal, Paul Wiegert took a new look at the possibility of a smaller asteroid striking Apophis. What could be the odds, he wondered, of such a strike putting the space rock on a collision course with Earth? He found that an object as small as 0.6 meters across could be big enough to knock the asteroid into a collision course sometime past 2029. He also found that an object just 3.4 meters across could strike with enough force to push Apophis into a collision course with Earth by 2029. However, his calculations showed that the odds of an object striking Apophis at just the right angle to alter its course toward Earth to be roughly 1 in 2 billion, with the chance of that leading to an eventual impact estimated at 1 in a million. To put this into perspective, currently, the asteroid's chance of hitting Earth in the next 100 years is so small, it's about 1 in 2 billion, making it statistically safer than just about anything we do on Earth. Meanwhile, the closest any other space rock will come to Apophis in the next few years is 4544 Xanthus. In December 2026, the asteroid Apophis will have a close encounter with asteroid Xanthus, with their minimum orbit intersection distance being less than 10,000 kilometers. Xanthus will pass this intersection point just 4 hours after Apophis. The minimum physical distance between the two asteroids will be about 528,000 kilometers on December 25, 2026. But if we were to discover that Apophis is on a collision course with Earth during one of its upcoming flybys, there would still be time to act. Just as a minor impact could nudge the God of Destruction toward Earth, a carefully planned intervention, like NASA's DART mission, could potentially deflect it away. With enough warning, a similar kinetic impactor could be deployed to alter its course and avert disaster. What do you guys think? Drop in your comments to let me know. If you like our videos, please become a member to support us. And while we are at it, let's talk about the space rock that's recently made headlines. Asteroid 2024 YR4. While updated calculations suggest it's unlikely to hit Earth, they now indicate a possible impact with the Moon. The threat posed by near-Earth objects is generally low but remains a significant concern due to their potential to cause regional or even global devastation. These space rocks, which orbit near Earth, are continuously monitored to assess their impact risk. Thankfully, most detected asteroids fall into category 0 or 1 on the Torino scale. Others, particularly new discoveries, may initially be placed in higher categories, but as their trajectories are refined through further analysis, they are usually downgraded. Now, there are numerous observatories that are dedicated to tracking NEOs. However, on 8 March 2025, the JWST observed asteroid 2024 WIRE-4, confirming that it poses no threat to Earth in 2032 or beyond. This marks it as the smallest asteroid Webb has ever studied and one of the tiniest whose size has been directly measured. Using its near-infrared camera, Webb captured reflected light from the asteroid, while its mid-infrared instrument detected thermal emissions, providing valuable insights into its composition and properties. The findings indicate that the space rock lacks the characteristics of larger asteroids, possibly due to its rapid spin and a rocky surface devoid of fine-grained sand. Instead, 2024 WIRE-4 appears to have a surface composed of fist-sized or larger chunks of rock. Webb's observations also determined its width to be approximately 60 meters, comparable to the height of a 15-story building. And while it is off the impact list, it remains under close observation by the Near-Earth Objects Coordination Center in Italy, in collaboration with NASA and other international bodies to further refine its orbit. However, the asteroid might hit the Moon. A new research suggests that there is about 4% chance of the asteroid's direct collision with the Moon. Some scientists believe that if the impact occurs, it could provide a unique opportunity to study a freshly formed lunar crater. While it would have no effect on Earth, it would mark the first time researchers could observe the formation of a lunar crater caused by a known asteroid. The Alpha Centauri star system consists of 3 stars, Alpha Centauri A and B, locked in a binary dance, and Proxima Centauri, a faint red dwarf. This entire system is moving toward us at a speed of 22 kilometers per second, or about 79,000 kilometers per hour, making it an ideal subject for studying how material travels between solar systems. In roughly 28,000 years, Alpha Centauri will reach its closest approach to us, about 200,000 astronomical units from the Sun. Scientists believe that material ejected from this system can and will reach us, and in fact, some of it may already be here. Existing models of material ejection from star systems are based partly on how our own solar system expels matter, and the researchers built their work on these models. Their findings suggest that Alpha Centauri may have ejected a significant amount of material, estimating that around 1 million particles larger than 100 meters in diameter are already within our Oort cloud. This animation that tries to bring the research to life shows our Sun marked in a black hexagon, and its orbit is shown as a gray solid line. Alpha Centauri is represented by the yellow star, with its orbital path shown as a blue solid line. The study visualizes how Alpha Centauri moves through the galaxy and tracks the movement of material it ejects, some of which may already be in our solar system. However, the simulation shows that while particles from Alpha Centauri could plausibly reach our solar system, their size matters. According to the scientists, small particles, those that would appear as meteors in Earth's atmosphere, are unlikely to make it. They face numerous obstacles along their journey, including magnetic fields, drag from the interstellar medium, and potential destruction through sputtering or collisions. But the research also found that some material from Alpha Centauri have already reached our solar system, with most of it traveling for less than 10 million years. It's fascinating to imagine that when their journey began, dinosaurs roamed the Earth, and the age of mammals had yet to begin. But to survive the journey, these particles must be larger than about 10 microns. Researchers estimate that around 10 Alpha Centauri particles currently enter Earth's atmosphere as detectable meteors, a number expected to increase tenfold over the next 28,000 years. This research reinforces the idea that our solar system is not isolated. If material can travel between star systems, it offers valuable insight into how planets form. Getting a clear understanding of how material travels from Alpha Centauri to our solar system not only enhances our knowledge of interstellar transport, but also sheds light on the interconnected nature of stellar systems and the potential for material exchange throughout the galaxy. In 2017, astronomers detected an unusual object that passed through our solar system, which was later named Oumuamua. Its name means messenger in Hawaiian, reflecting its status as the first interstellar object ever observed. The cigar-shaped object, estimated to be about 800 meters long and 80 meters wide, came from outside our solar system, traveling at a speed that indicated it wasn't bound by our sun's gravity. This made it an intriguing subject for study, as it provided scientists with an unprecedented opportunity to observe an object from another star system. However, its origins, composition, and even its unusual motion left many questions unanswered. 2 years later, in 2019, another interstellar object, a comet named Borisov, was discovered by astronomers. Unlike its predecessor, Comet Borisov came with a tail displaying typical features of a comet, such as a bright and expansive coma. The comet, moving at a high velocity, had also come from outside the solar system and was the second known interstellar object to pass through. Borisov's trajectory suggested it was not bound to the Sun either, and it would eventually continue its journey out of the solar system. While both Oumuamua and Comet Borisov were fleeting visitors, their appearances marked significant milestones in astronomy, suggesting that interstellar objects might be more common than we initially thought. This raised a very important question. How many other objects from our stellar neighbors could be visiting our solar system? A new research examines the amount of material from nearby stars that could reach our solar system. Their findings suggest that some of these interstellar visitors, originating from our neighboring star system Alpha Centauri, may already be here. The Alpha Centauri star system consists of 3 stars, Alpha Centauri A and B, locked in a binary dance, and Proxima Centauri, a faint red dwarf. This entire system is moving toward us at a speed of 22 kilometers per second, or about 79,000 kilometers per hour, making it an ideal subject for studying how material travels between solar systems. In roughly 28,000 years, Alpha Centauri will reach its closest approach to us, about 200,000 astronomical units from the Sun. Scientists believe that material ejected from this system can and will reach us, and in fact, some of it may already be here. Existing models of material ejection from star systems are based partly on how our own solar system expels matter, and the researchers built their work on these models. Their findings suggest that Alpha Centauri may have ejected a significant amount of material, estimating that around 1 million particles larger than 100 meters in diameter are already within our Oort cloud. This animation that tries to bring the research to life shows our Sun marked in a black hexagon, and its orbit is shown as a gray solid line. Alpha Centauri is represented by the yellow star, with its orbital path shown as a blue solid line. The study visualizes how Alpha Centauri moves through the galaxy and tracks the movement of material it ejects, some of which may already be in our solar system. However, the simulation shows that while particles from Alpha Centauri could plausibly reach our solar system, their size matters. According to the scientists, small particles, those that would appear as meteors in Earth's atmosphere, are unlikely to make it. They face numerous obstacles along their journey, including magnetic fields, drag from the interstellar medium, and potential destruction through sputtering or collisions. But the research also found that some material from Alpha Centauri have already reached our solar system, with most of it traveling for less than 10 million years. It's fascinating to imagine that when their journey began, dinosaurs roamed the Earth, and the age of mammals had yet to begin. But to survive the journey, these particles must be larger than about 10 microns. Researchers estimate that around 10 Alpha Centauri particles currently enter Earth's atmosphere as detectable meteors, a number expected to increase tenfold over the next 28,000 years. This research reinforces the idea that our solar system is not isolated. If material can travel between star systems, it offers valuable insight into how planets form. Getting a clear understanding of how material travels from Alpha Centauri to our solar system not only enhances our knowledge of interstellar transport, but also sheds light on the interconnected nature of stellar systems and the potential for material exchange throughout the galaxy. Astronomers, using a new analysis of James Webb Space Telescope images, have discovered a surprisingly large number of small, main belt asteroids. This discovery could alter estimates of Earth's impact rates from objects ranging in size from a house to a stadium. While calling something the size of a stadium might seem massive, But in the vastness of our solar system, it's merely a grain of sand. The Webb telescope also focused its attention on a mysterious asteroid-comet hybrid, lurking past Jupiter, and its properties are unlike anything we have ever seen before. Welcome to territory. This is your space. A new analysis of archival Webb telescope data has revealed an unexpectedly large population of asteroids ever seen in the asteroid belt between Mars and Jupiter. Just a decade ago, an asteroid only tens of meters wide caught everyone off guard when it exploded over a Russian city, unleashing energy 30 times greater than the atomic bomb dropped on Hiroshima during World War II. The newly discovered asteroids, however, range from the size of a bus to several stadiums, small compared to the colossal space rock that caused the dinosaurs' extinction, yet still capable of delivering a powerful impact. These asteroids strike Earth 10,000 times more often than their larger counterparts, but their small size makes them difficult for surveys to detect early. A team of scientists from the Massachusetts Institute of Technology made this discovery by repurposing Webb's observations of the TRAPPIST-1 star, and while doing so, uncovered a population of small asteroids in our asteroid belt. I know what you are thinking. Do these newly discovered space rocks pose a threat to Earth? Well, larger main belt asteroids orbiting between Mars and Jupiter typically stay in stable paths. In contrast, smaller ones are more often nudged by gravitational forces, potentially sending them into the inner solar system as potential impact threats. The discovery of at least 5 times more small objects in the main belt than anticipated may influence estimates of how often such impacts occur. JWST is particularly good at finding asteroids because they're much brighter at infrared wavelengths, and these asteroid findings fill a crucial gap in understanding the origins of meteorites and larger asteroids that could pose a threat to Earth. According to the new study, future JWST observations will target 15 to 20 distant stars for at least 500 hours, potentially uncovering thousands more small asteroids in our solar system. This will surely help put our planetary defense in a much better place. What do you guys think? Let me know in the comments below. Meanwhile, the James Webb Telescope has turned its focus to a peculiar space rock located between Jupiter and Neptune. This strange centaur, known as 2060 Chiron, exhibits characteristics of both comets and asteroids. Chiron orbits the Sun about once every 50 years, traveling in an oblong loop in the region between Jupiter and Neptune. The team found carbon dioxide and methane gases in its coma, the cloud of gas and dust, around the nucleus. Astronomers also detected water ice and lightweight carbon-containing molecules like ethane and propane for the first time on a centaur. These results are like nothing we've seen before, study co-author Charles Chambaud said in a statement. Detecting gas coma around objects as far away from the Sun as Chiron is very challenging, but JWST has made it accessible. Objects like Chiron haven't changed much since the solar system first formed, so observing how they interact could help scientists better understand the early solar system, said another scientist. However, Chiron, like all centaurs, is currently in a transitional state, and its ultimate fate will unfold over the next million years. It may either be drawn back into the inner solar system by Jupiter's gravitational influence, transforming into a Jupiter family comet with an orbital period of less than 20 years, or it could be ejected back into the Kuiper belt, cast out by the gatekeeper Jupiter. While the outcome remains uncertain, much like its namesake from Greek mythology, its future rests in the hands of the universe. While Chiron's fate unfolds closer to home, another remarkable discovery lies waiting at the distant edge of our solar system. Launched in 2006, NASA's New Horizons is one of the fastest spacecraft ever built, blazing through space at over 36,000 miles per hour. Its primary mission was to explore Pluto, a once mysterious icy world lurking in the dim outskirts of the solar system, over 3 billion miles from the Sun. But New Horizons didn't stop at Pluto. The spacecraft pushed onward into the eerie and largely unexplored Kuiper belt, a colossal ring of frozen bodies and ancient debris that circles the Sun beyond Neptune. This vast region, spanning a staggering 2 billion miles, is a frozen graveyard of the solar system's formation, littered with icy rocks, dwarf planets, and comets that have been preserved in a deep freeze for billions of years. Today, from over 5 billion miles away from its home planet. New Horizons is still sending data back, transmitting faint signals that take over 6 hours to reach Earth. But the spacecraft's work is far from over, and it is heading out deeper into the solar system, and currently it is at 60 astronomical units from the Sun. The vast distance of the Kuiper belt from the Sun means that anything within the belt is very minimally affected by solar radiation. That, in turn, means that Kuiper belt objects likely have largely remained unchanged since the formation of the solar system some 4.6 billion years ago. This makes the KBOs the ancient remnants of the cloud of material known as the solar nebula, from which the Sun and planets formed. Now, to support New Horizons' ongoing exploration at the edge of the solar system, astronomers here on Earth have been conducting observations of the Kuiper belt using the National Astronomical Observatory of Japan's Subaru telescope. To date, the Subaru observations have revealed 263 new Kuiper belt objects. However, in a plot twist, a large international team of astronomers, led by Wesley Fraser of the National Research Council of Canada, has found objects much farther away, challenging our planetary models. Yes, hints of a hidden structure has been detected at the edge of the solar system. Observations showed that 11 of these objects are located way beyond where we thought the Kuiper belt ended, in a region over 70 astronomical units from the Sun. But that's not even the crazy part. Based on the number of these objects found, researchers have estimated the density of the outer Kuiper belt ring. They found that while it is lower than the inner regions, it is still dense enough to have or form a new structure. And between the Kuiper belt and the newfound structure, there is a region where almost nothing has been found. Yes, a mysterious gap. But is it really mysterious, though? While it might seem a bit strange, such gaps are common in other forming planetary systems, aligning our solar system with what we've observed elsewhere in the galaxy. Many observations of the Milky Way suggest that our solar system is quite unique. Since it's the only known planetary system with life, these unusual features might play a key role in making the solar system habitable. But if the discovery of this structure is confirmed with more observations, it will tell us that our star system isn't that unique after all. Our solar system's Kuiper belt long appeared to be very small in comparison with many other planetary systems, but our results suggest that idea might just have arisen due to an observational bias, Fraser explained. So maybe, if this result is confirmed, our Kuiper belt isn't all that small and unusual after all, compared to those around other stars. Yes, our space observation technology has its limitations, which can lead to biases that make certain features seem unusual when they might not be. If the new Kuiper belt findings are confirmed, we can rule out one of these supposed oddities, a smaller than expected solar nebula. To better understand this discovery, astronomers are continuing to track the orbits of these 11 distant objects. This is a groundbreaking discovery, revealing something unexpected, new, and exciting in the distant reaches of the solar system, said New Horizons principal investigator Alan Stern of the Southwest Research Institute. This discovery probably would not have been possible without the world-class capabilities of Subaru Observatory. While we set our sights on finding life beyond Earth, it's fascinating to realize how much we still don't know about our own solar system. What do you think? Drop in your comments to let me know. And don't forget to subscribe to Territory, because this is your space.